Right, question 8. 7 marks. So the clue here, it's quite a simple expression of the question. It's, there's not a lot of words in there, there's not a lot to go with, but for 7 marks we're going to expect that we've got quite a lot to work out with this. The quadratic equation kx squared plus 3k minus 1x minus 4 has no real roots. Find the set of possible values of k. It's quite clever this, because they've brought lots into this question. This is, on the surface of it, it's just a question about the discriminant, about b squared minus 4ac. But then it's going to lead us into a quadratic inequality as well. So it ties into quite a lot of the polynomial stuff that we've been doing about. So, it has no real roots. That's the first bit we're looking at, and that tells us that that means that b squared minus 4ac is less than 0. No real roots. So we've got to work on that now then. So b squared, 3k minus 1 squared, minus 4 times a, which is k, times c, which is minus 4, is less than 0. So again, you see we've got the negative signs. We're making a big deal about this today, that we make mistakes with that and we're going to be really careful. This first bracket, multiply it out, and you're going to get 3k times 3k, so 9k squared, minus the 3k, minus another 3k, and then this 1. And then this bit is minus 4 times k times minus k. Times minus 4, sorry. Minus 4 times k times minus 4. What's that going to give us? Say it? No. I think he refused to say plus 16. Okay, are we all happy with that? It's less than 0. So we've ended up with our equation saying 9k squared plus 10k plus 1 is less than 0. It's a kind of vaguely familiar quadratic, isn't it? With a square number at the start and 1 at the end of it. We've had another one like that a few minutes ago. Let's see if we can do anything with it. Does it factorise? Well, 9 times 1 is 9. 2 things are multiplied to give 9 and add to give 10. I can think of 2 things. So that's going to work. So let's go with that. We've got 9k squared is going to be 9k and k. So we're going to write this as being 9k squared plus 9k plus k plus 1, which does factorise 9k as a common factor there, k plus 1, and we'll put the other one in brackets, k plus 1. And so, you may have got that there quicker doing it another way, but we've ended up with k plus 1 and 9k plus 1. And the thing to do when we've got a quadratic inequality like this is that it's important that at this point we don't jump straight into saying that k is less than minus 1 and k is less than minus 9, because we can't deduce that straight away. At this point, I like to write that what we've got here are critical values. In this curve, we can identify values that are important. They are k as being minus 1 and k as being minus 1/9. They're the critical values. They're the 2 values that make the bracket 0. Now those values would give us b squared minus 4ac equals 0. So they would give us real repeated roots. But we want to know when it's less than 0. What we've got here, this line here, is a quadratic equation in k. And if we were to draw a graph of that quadratic equation, y equals 9k squared plus 10k plus 1, on axes where we've got a k-axis and a y-axis, if you like, there, then the graph would look, I've not drawn this terribly well, not bad, but the graph would look like that, where these 2 points are -1 and -1/9. I don't think you can read that. And we want to know when the graph is negative. When is it dipped underneath the horizontal axis? Well, it's dipped underneath between these values, hasn't it? In that range there, we've gone underneath the axis. So they're the values that we want. So our solution is k is bigger than -1 and less than 1. It's important that we use strict inequality signs there as well. Why must we use strict inequality signs and not or equal to ones? What does it mean to use or equal to ones in that context? It would be equal to 0 at that point, which is where it has repeated roots. And that's no good. It distinctly said they had to be not real roots. So there we go. I think that's all of that. That was not bad for 7 marks, though, was it? Okay, and that's maths.